Amylase is a digestive enzyme that catalyzes the breakdown of complex carbohydrate, which is starch, into simple sugar. It is a massive powerhouse in the real world. It is used to ferment grain by the breweries, to make corn syrup by the factories, and to keep bread soft on the shelf by the commercial bakeries. We all love rice mochi. It is soft, sweet, and perfectly chewy. But if you have ever tried making traditional mochi at home, you will know the heartbreak that happened the next day. It's turned into a rock hard lump. But think about the mochi we buy at the store. You can leave it on the counter for days or even weeks, and it stays perfectly soft and chewy. How is that possible? The secret is the enzyme called amylase. In the food industry, amylase is added to mochi to break down starch, preventing them from stalling and getting hard. Today, our group is going to show you exactly how this works.
Now, I would like to explain the enzyme used in this study, which is alpha amylase. Alpha amylase is a starch-degrading enzyme that belongs to the hydrolase enzyme group. It is widely used in the food industry, particularly in bakery and starch-based products, because of its ability to modify starch property and improve product quality. The main function of alpha amylase is to break down starch into smaller carbohydrate molecules. In this food product, this can help improve texture, enhance softness, and reduce firmness. It may also contribute to slight sweetness due to the formation of simple sugar. In this study, alpha amylase was selected because mochi is primarily made from glutinous rice flour, which contain a high amount of starch. By modifying the starch structure, the enzyme may help produce a softer and more desirable texture while improving overall sensory acceptance. Therefore, 0.01% alpha amylase was added to the mochi formulation to evaluate the effect on texture and sensory properties. To understand how alpha amylase performs this function, the enzyme mechanism will be explained next.
To make the enzyme mechanism easier, you can first understand the key term. First, the substrate, the specific substance an enzyme add upon, and in our case, is the starch. The active site, the region on the enzyme where the substrate binds and the chemical reaction happens. And the hydrolysis, which is the chemical breakdown of a compound due to reaction with the water. And last is the retrogradation, the process where heated starch cool, analyze and recrystallize, causing stalling or hardness in the food. So what's actually happening to our mochi at a molecular level? It all comes down to alpha amylase, a fascinating enzyme that acts as the microscopic scissors. Mochi is packed with starch, specifically amylose and amylopectin. Alpha amylase studies this long chain by binding at the active site, and through hydrolysis, the enzyme breaks the internal bond of the starch, chopping those long tangled chains into smaller, sweeter sugar like maltose or dextrin. Why does this matter for our experiment? Normally, as mochi cools, the starch undergoes retrogradation, the chain lock together, making the mochi turn hard and stale. By introducing alpha amylase, we interrupt this process, and the shorter sugar chain cannot lock together as easily, keeping the mochi incredibly soft and giving them a natural sweeter profile over time.
Now, we already know the working mechanism of amylase towards starch. So how does this apply to our kitchen lab? To find out, we designed an experiment using glutinous rice flour, which is the core ingredient to make mochi. The objective of our experiment is to investigate how the addition of amylase into the formulation of mochi affects its texture and stickiness. There are two formulations for this experiment, which are without amylase that act as control, and with amylase. The mochi containing amylase is expected to be softer and less sticky compared to the one without amylase. These are the result of the written gel network of the hydrolyzed starch.
Next, I will explain the variable used in this study. The independent variable is the addition of 0.01% amylase enzyme in the mochi formulation. The dependent variables are the texture and physical characteristic of the rice mochi, especially its softness, elasticity, and overall quality. After preparation, several control variables were maintained throughout the experiment to ensure a fair comparison. These include the amount of glutinous rice flour, corn flour, milk, cooking oil, and salt used in the formulation. In addition, the cooking process, mixing procedure, enzyme concentration, and storage condition at room temperature were kept constant for all samples. By controlling these factors, any difference observed in the mochi can be attributed to the presence of the amylase enzyme. To evaluate the effect of amylase enzyme, two experimental groups were prepared. The control group, labeled as Control C, consists of rice mochi prepared without amylase enzyme. The treatment group, labeled as Treatment E, consisted of rice mochi prepared with 0.01% amylase enzyme added into the mixture. Both groups were prepared using the same formulation and processing condition. The experiment was conducted with 3 replicates, or n equals to 3, to improve the reliability of the results. The amylase enzyme functioned by breaking down alpha-1,4-glycosidic bonds into starch, into smaller reducing sugar such as maltose and dextrins. This action may influence the texture and softness of the mochi. By comparing the control and treatment sample, we can determine whether the addition of amylase enzyme has a significant effect on the quality of rice mochi. Thank you. Next, the result and discussion will be presented.
To start, I would like to guide your attention to this video showing our sensory panel in action. What you are seeing is a paired comparison test where our 29 panelists are evaluating two different samples of rice mochi, one traditional and one treated with the enzyme amylase. Amylase breaks down complex starches into simpler sugars, a process meant to alter both flavor and texture. Let's look at the data to see exactly how these changes measured out. Now, let's look at our hardness results shown in hardness chart. The instrumental data reveals a massive contrast. Our untreated rice mochi recorded a higher hardness value of 2,191.18, but with the addition of amylase, that hardness dropped drastically to just 58.59. This confirms that amylase successfully softens the mochi's structural network, resulting in a significant decrease in hardness. As for stickiness chart, we observe a similar spike here. The untreated mochi had a stickiness value of negative 6.24, whereas the enzyme-treated mochi jumped massively to negative 101.30, demonstrating a significant increase in adhesiveness. Next, we conducted a sensory pack comparison test with 29 panelists to see if human perception aligned with these instrument readings. Interestingly, our panelists found that sweetness was the only attribute with a statistically significant difference, with 25 out of 29 panelists identifying it correctly. This directly correlates with the amylase breaking starches down into sweet-tasting sugars. Surprisingly, despite the massive jumps we saw in the machine readings for the hardness and stickiness, our panelists found no significant differences in sensory attributes like softness, chewiness, or stickiness. In conclusion, amylase fundamentally improves the physical properties of rice mochi. Instrumentally, it yields a significantly softer and stickier product. Yet, from a consumer perspective, our panelists primarily notice a distinct and pleasant increase in sweetness, while the perceived texture remains indistinguishable from the control. This makes amylase an ideal industrial tool for natural sweetening and texture management. Thank you.
Can a tiny amount of enzyme change the texture of mochi? Let's find out. Today, we'll be making rice mochi and exploring its effect on mochi texture. To prepare our enzyme-treated mochi, we used glutinous rice flour, corn flour, full cream milk, cooking oil, salt, and amylase enzyme.